All right, so this is still Unit 1, and we're going to look at different ways that we can represent data. The first one we're going to look at is stem and leaf plots. I'm just going to run through an example here, and I'm going to use this table as our data source here. And I'll also do another version of this where we can look at this data in a different manner as well. And then we can kind of compare which one is more useful, which one's quicker, things like that. And some of these, one thing you need to remember about a lot of the things we'll talk about is that there's normally multiple ways to do it. And it's up to us as the statistician to figure out the best representation of that data and make recommendations, predictions based upon that best version. So it's not always that there's just the one version. There's probably multiple ways that we can do this, and we need to find the best representation that gets our point across and is also very accurate and true to the point. Now, also a quick disclaimer in terms of when we look at this, is we have computer systems out there that will do a lot of the analysis for us these days, and it's really worth your while as a statistician to learn how these mechanical pieces work, even though that there are systems out there that will do this. There are AIs out there where you can essentially give it the data source, tell you and ask it what you want, the questions you want the answers to, and it'll actually give you the answers and sometimes even the work itself. And that's fine if all you want is an answer, but here we're digging deeper than that. We're trying to figure out how these things work and how we can do with them, because then we can interpret them better, because a human is always going to be superior to machine in that interpretation process. And we do need to be careful, because one of the fundamental aspects of computer systems is they do lack morals and ethics, and sometimes those pieces do play a part in our interpretations. All right, now when we look at this, is what we have here is a data set, and this is international dollars, so this isn't necessarily US dollars or euros or whatever. It just says international dollars, and that's interesting designation in of itself, and we could read into what that means. But the biggest thing we're going to point out is that we have this data source here, and essentially what it's talking about is the health expenditures by country per person. Okay, so what they're saying is Argentina spends roughly $1,700 a person, India spends $200 a person, Russia spends $1,600 a person. And also notice what I'm doing there is I'm rounding, and in this case I'm using 5 as that point to round up or down to the nearest hundreds. And so we can look, and here's the US at 9,100. Okay, so the first thing we want to do when we want to build a stem and leaf plot is first identify how are we going to build the stem and how we're going to build the leaf. What do those two components look like? So we have lots of choices here, and in one version of this we can have lots of really big numbers. In other versions we can have much smaller numbers. So the thing we're going to do here is we're actually going to go through this data list here and simply convert all these to the nearest hundreds. So instead of 1725, it's going to be 1700. Instead of 4191, it's going to be 4200. Instead of 4885, it's going to be 4,900. And we're just going to go through the entire list like that, making that list out and just converting those numbers over. Not really concerned with which country they're attached to. We'll come back to that piece after we do the rest of the analysis here, and then we start interpreting the data, which is another piece of this that we're not getting to necessarily in this video. But when we get all this converted, then we need to define our stem and our leaf. Now, the reason we did that rounding process first was now we can designate the stem as the 1 and the leaf as the 7. The stem is the 4, the leaf as the 2. Remember the rounding, right? The stem is the 4, the leaf as the 9, going through that rounding process. So this is the process I went through. I took 1725, I converted it to 1700, which is the nearest rounding, and then I converted that into 1 and 7 for the stem and the leaf. And then I just went through and I created my stem and leaf plot. And all I did was go through the entire list and look at what each set of values were doing. So, and I tried to keep these lined up as best I could. I got a little bit out of order, but for the most part, they're pretty much lined up. And what we can now do when we look at this data set is that we have a much better representation, or much more easily definable representation, what we can look at here, of what's going on with individual pieces of data. Namely, we can see that between 0 and 1 here, between hundreds of dollars and $1,700, there's a lot of data there. And then we have just 4 countries here, 1, 2, 3, 4, and then we have several countries, 1, 2, 3, 4, 5, 6, 7 countries, because that's remember those how many, these leaves here represent each country attached to 4,000. And there is almost all of the countries that are in this data set. And then we have 1, 2, 3, 4 countries beyond that, right? So here's our stem and leaf plot. Now, why this is useful to us is because it kind of gives us this histogram look of it, especially if you were to turn it sideways. You can kind of see underneath that how I've created a curve based upon that data set, so we can kind of see that it does that. Well, where's most of our data at? Well, we had several countries there, and we could actually count up the number of countries we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. All right, so 33 countries is what we have. So maybe 30, yeah, I guess 33. So what that means is 16, 16, I guess 16 and a half would actually be the center point of that. So if we count out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oh, I went too far. I'm sorry, let's stop that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So right here, that spot right there, and turn back around this way if it's easier to look at it that way, that represents half the data. Half the data is in front of that line, half the data is behind that line. All right? Which creates an interesting perspective difference for us. If we have this lined up correctly, which hopefully we do at least, that's kind of powerful in that when you look at half the countries are spending less, $1,700 or less on healthcare. Remember, we rounded this up, so this might actually have been $1,685 or something like that. I don't remember the exact value. And then half the countries are above that. Now, with the United States being what we call an outlier. Again, so this is another strength of doing this. It's a very quick process that we went through to create this graph, if you will. And you're thinking it's a bunch of numbers, and that's all graphs are, just a bunch of numbers represented in a geometric fashion of some sort. It gives us some type of physical structure that we can look at the information and draw stuff out. We see the United States at $9,100 per person, which is $9,146 per person, is an outlier. It's outrageously more money than most of the other countries. Half of the countries are $1,700 or less. If we were to think about 3,300 countries divided by 4, if we want to split this up into quarters, well, we can do the quick version of this. Half of 16 would be 4 1/4. So that'd be 16 and a half plus 4 1/4, which is 20 and 7/5, right? Which somewhere in between 20 and 21 is where we're going to be talking about being a quarter. So if this was 16, 17, 18, 19, 20, 21, right there. 75% of the nations that were listed there lie below that spot. So 75% of the countries spend $3,100 or less on healthcare. Okay, or $3,100 or less on healthcare. And then 25% of the countries spend more than that much. Now, what does this mean from a equity basis or equality basis, or who has the best system? That's not really the discussion that we're having here. All we're doing here is looking at, well, what is the breakdown of this? And what we've just figured out is that most of the countries lie below this mark. And we say most, in this case, we're talking about 75% of them. And we could even go through and figure out how many, what percentage the United States is, or how many of them spend less than 6,000, which would be from here down. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9 countries that added to the 20. So that would give us 29 countries. And then we could say, well, 29 divided by 32. And we could figure out, if we were to put another line right here, here's the 75% mark, here's the 50% mark. We could figure out what this mark was as well. And just simply by doing that and figuring out what that percentage is. I shouldn't put an equal sign, I should put an arrow like that, saying what's that percentage amount right there that's below that. And that could be really telling for us and very useful for us when we're starting to decipher and figure out what this data is telling us. furthermore, when we look at this right here, this graph gives us a pretty good indication that our data here is skewed right. Now again, remember this always works backwards, okay? Meaning that most of the information, we moved that mean, if you will, or the median in this case is what we found. We've moved the mean over to the right, which means our information, not to the right, we've put half the information above and half the information below. So the span above is much longer than the span below that halfway point. So this is skewed right because that right piece is longer than it's supposed to be if this were symmetrical. Okay, so this is skewed right because it's been pushed left. Now that seems backwards, but what you're really doing is you're looking at what's the length on either side. The length on the right is longer than the length on the left, so it's skewed right because the right is longer. Okay, and that is really useful too because again, you're talking about this being the 50% mark, right? And that's kind of an interesting aspect. We're talking about right here is the 75% mark, right? And then over here somewhere, that was the 5,600 and whatever that ended up being, whatever percentage that ended up being. We didn't figure that out yet. But this can be really useful in that when we start looking at the data, start interpreting the data, what all can we learn from this? And this is just a place where this building this histogram based upon a stem and leaf plot can do that for us and all the pieces that we can pull out of there. Okay, thank you.